Have you ever paused, like really considered how the incredibly powerful devices we rely on daily get so small? Your smartphone, that smartwatch, even the tech in your car.
Hmm.
How does it all fit? What if I told you there's this microscopic, invisible process behind almost all of it? I was digging into a report on this, and honestly, it's pretty mind-blowing. Okay, let's unpack this. Today, we're doing a deep dive into something called surface mount technology, or SMT for short. It's basically the bedrock of modern electronics manufacturing. And our insights for this exploration come from a really detailed report by Cognitive Market Research. It came out February 2025, got an update in June 2025. So our goal today is simple: give you a clear, sort of concise understanding of this, well, absolutely vital industry.
Yeah, SMT, at its heart, is a way to put electronic components straight onto the surface of a printed circuit board, PCB.
Sure.
It's quite different from the older through-hole way of doing things. And it's become, well, just essential in modern electronics. It allows for smaller, lighter parts and really boosts production efficiency massively.
Right. And that direct mounting, that precision you mentioned, that's the real game changer
Yeah.
compared to poking component legs through holes in the board. We're talking tiny resistors, capacitors, complex chips, all sitting right on the surface, placed incredibly accurately. It's not just a small step. It's like a total shift in how we build electronics,
Yeah.
from watches to advanced medical gear.
Exactly. That's precisely why SMT is so pivotal. It's the engine, really, behind the miniaturization we see everywhere. Think about your phone. Seriously. Without SMT, it'd probably be, I don't know, the size of a brick. Totally impractical. And it's not just about making gadgets smaller for convenience. It enables whole new kinds of devices, portable, connected things. Its impact is, well, it's everywhere. Telecom, automotive, cars needs super complex, compact boards now. Consumer gadgets, even critical healthcare stuff.
It really is eye-opening when you think about it that way. How this one, sort of hidden technology, underpins so much of modern life, from your hand to your car dashboard. Okay, so beyond the what and why, let's talk numbers. Because the scale of this market is pretty staggering. The SMT market back in 2024 was valued around USD 600 and 251.6 million. And it's definitely not static. It's projected to grow at a compound annual growth rate, that's the CAGR, basically steady year-on-year growth of 5.5%, which means it could hit, get this, USD 900 and 594.2 million by 2032. That's some serious momentum.
Okay.
Here's where it gets really interesting.
What's fascinating here is why it's growing like that. It's plugged into several big trends you probably see around you. First, just the sheer volume, the increasing adoption of consumer electronics. Everyone wants the latest, smallest thing, right? That links directly to the miniaturization trend we talked about, making things smaller and smaller. Then there's the boom in automotive electronics. Cars are becoming computers on wheels, needing these dense, compact boards.
Yeah.
And, of course, you've got 5G rolling out, the Internet of Things, IoT, all that needs advanced electronics, and SMT is, well, essential for it. What's fascinating here is you can see how it all connects. These drivers feed into each other, and the bigger tech shifts we're living through.
So where's the hub of all this activity? Who's leading the pack globally? If we look at the breakdown for 2024, North America had a pretty big slice, about 30% of the market. Strong manufacturing, lots of R&D there. Europe was close behind, around 28%. They have a strong industrial base, especially automotive and consumer electronics. But the leader was Asia Pacific, holding about 32%. Think China, Japan, South Korea, they're really driving it.
And if we connect this to the bigger picture, the growth in Asia-Pacific is really the story to watch. It's expected to grab even more share, maybe 35% by 2025. And crucially, it's projected to have the highest growth rate, that CAGR we mentioned, around 7% over the forecast period.
That tells you where the big investments are going, where the demand, especially for consumer and auto electronics, is just exploding. It really highlights Asia's central and growing role in global manufacturing. It's a major shift.
And what about the companies actually making the SMT equipment? Who are the big players?
Well, in 2024, the report highlights Fuji Machine Manufacturing Co., Ltd., as the leader, with about 18% market share. Then you have Yamaha Motor Co., Ltd., yes, the same Yamaha with 15%, and Mycronic at 12%. And their strategy seems to be, heavy R&D investment, smart mergers, acquisitions, partnerships, staying ahead of the curve. But interestingly, the forecast suggests we'll see new players popping up by 2025, especially, again, in that booming Asia-Pacific region. So competition might heat up even more. It'll be interesting to watch.
Okay, so we've mentioned older methods like through-hole, and there are others like chip on board. Given these alternatives, what really gives SMT its edge? Why is it so dominant? Yeah, it really does dominate. Back in 2024, SMT had something like 55% of the whole electronic assembly market. Through-hole, the older way, was around 30%. and chip on board, or COB, maybe 15%.
Big difference.
Huge. And SMT's share is even expected to nudge up a bit, maybe to 57% by 2025.
Yeah.
The why is pretty clear. It's just better suited for modern needs. It can handle much smaller, lighter components. It allows for way more complex designs, putting more stuff in less space. You get more flexibility in placing components, and critically, it supports much higher levels of automation.
Right. Efficiency.
Exactly, which means faster, more efficient production. And that ties right back to the demand for compact, powerful devices. That's why, your tiny wireless earbuds can do so much.
It sounds incredibly capable, enabling all this tech we use, but, no technology is perfect. What are the downsides? What challenges does SMT face?
That's a fair point.
Mhm.
There are definitely limitations, hurdles. One big one is its sensitivity to the environment. Things like temperature swings, humidity, they can really affect the solder joints, the connections between the component and the board.
How so?
Well, extreme temperatures can cause stress, leading to tiny cracks or even failures over time. And this is a major concern in sectors like automotive or aerospace, where reliability is absolutely critical. You just can't have failures.
Yeah, makes sense.
And beyond that, the SMT machines themselves, they're incredibly precise, but that also makes them vulnerable. Mechanical vibrations, even tiny amounts of dust, can mess with the accuracy and slow things down. So you need really strict quality control, clean room environments, and that adds to the cost, naturally.
Right.
Plus, the machines are complex. A small error somewhere in the line, that can cause big production delays. So you need sophisticated monitoring systems. This raises an important question. How does the industry deal with these issues? And the answer is, well, constant effort. They're always working on improving materials, processes, and monitoring to make SMT even more robust and reliable.
Okay, so challenges exist, but the industry is working on them. Looking forward, then, what's next for SMT? Especially with things like automation and AI really taking off.
Oh, the future is definitely dynamic. We're already seeing big steps. For instance, back in September 2023, Panasonic launched a new series of SMT machines, the NPMG series, in India. These are all about boosting fully automated production lines. Think higher speed, more flexibility, better precision.
So faster and smarter assembly?
Exactly. It shows the push towards greater efficiency to meet global demand. And looking further out, a big trend is integrating more artificial intelligence, AI, and machine learning, ML, right into the SMT machines.
How would that help?
Well, imagine machines that can monitor themselves in real time, predict when they might need maintenance before they break down.
Predictive maintenance, right?
Yes. And even adaptive manufacturing, where the machines can learn and adjust processes on the fly for optimal results.
Hmm.
Plus, the push for even more miniaturization isn't stopping. That means we'll need machines that are even more precise, capable of handling incredibly tiny components and packing them closer together. So basically, the SMT market has to keep evolving, keep innovating to provide the advanced, reliable assembly solutions that all these changing industries demand. It's paving the way for whatever comes next in smart devices.
So what does this all mean? We've seen SMT isn't just some obscure manufacturing technique. It's fundamental. It enables the small, powerful electronics that shape our world. It's a market with serious growth ahead, driven by our hunger for better tech. But it also faces real challenges, like environmental factors that require constant innovation. And its future seems tied to getting smarter, more automated, more precise, driven by AI and robotics.
Absolutely. SMT is just pivotal. You can't overstate its importance in the whole electronics ecosystem. Its future really depends on tackling those limitations, innovating constantly, and building strong partnerships across the industry. By doing that, it'll keep optimizing how things are made, meeting that ever-growing global need for precision, for smaller scale, for automation. It's truly the hidden engine powering our digital age.
So here's a thought to leave you with. As our world gets even more connected, as devices inevitably shrink further and get smarter, how will this unseen precision of SMT continue to shape what's even possible? What completely unexpected innovations might this quiet, relentless technology unlock next?